In this example, we're asked to determine the point of intersection of the two linear functions. So we could do this graphically or algebraically, and for this problem, we'll go over both methods. Notice that both linear functions are in slope-to-intercept form, or the form y equals mx plus b, where m would be the slope of the line and b would be the y-intercept of the line. So if we want to, we can rewrite the first linear function as y equals negative 2x minus 4. Notice the slope, or m, is equal to negative 2, which we'll write as negative 2 over 1. It's always helpful to have the slope as a fraction when graphing the line, and the y-intercept is equal to negative 4. So let's go ahead and graph this first linear function. Again, the y-intercept is negative 4. The slope is negative 2 over 1. So from here we go down to right 1, down to right 1, and our line will pass through these 3 points. And for our second linear function, we can rewrite as y equals x plus 8. The coefficient of the x is 1, therefore the slope of this line is 1, or 1 over 1, and the y-intercept is equal to positive 8. Now we'll graph this line to determine the point of intersection. So here's our y-intercept. The slope is 1 over 1, so up 1, right 1. The second line will pass through these 2 points. Now that we've graphed the 2 lines, we can see the point of intersection would be this point here, where the x-coordinate is negative 4 and the y-coordinate is positive 4. But graphing to determine points of intersection is often not the easiest method because we have to graph very accurately, and unless the point of intersection has integer coordinates, it's often difficult to determine the actual coordinates. So let's also show how to solve this algebraically. To determine the point of intersection algebraically, we need to determine when these functions are equal to each other, or when f of x is equal to g of x. Well, this is going to occur when negative 2x minus 4 is equal to x plus 8. So let's go ahead and set up that equation and solve for x. So we'll go ahead and subtract x on both sides of the equation. So we have negative 3x minus 4 equals, this would be 0, and then positive 8. So add 4 to both sides. This would be 0, so we have negative 3x equals 12. Divide both sides by negative 3. So we have x equals negative 4. But remember, we're looking for the point of intersection, so we need both the x-coordinate and y-coordinate. So now that we know the x-coordinate is negative 4, we need to go back and find the y-coordinate, which would be the function value using either function. So if we use function g of x, we're going to determine g of negative 4 to determine the y-coordinate, which will just be negative 4 plus 8. So g of negative 4 is equal to positive 4, which means the y-coordinate of the point of intersection would be positive 4. So here we use function g, but we could also have used function f. F of negative 4 would also be equal to positive 4. So whether we determine the point of intersection algebraically or graphically, of course the point of intersection will be the same.